Okay, angles in trigonometry. So we're working up to the unit circle. We're almost there. An angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the x-axis. So we always draw them like this. So see how that's lying on the x-axis there? So that part. And then the other one is doing whatever it wants, and then it goes counterclockwise. The ray on the x-axis is called the initial side, and the other ray is called the terminal side, okay, because that's where it terminates or that's where it stops. Clockwise rotations result in positive angle measures. Clockwise are negative angle measures, and one full revolution is 360 degrees. Okay? So let's draw some angles. So first, what I'm going to do here, that's my 0 degrees. So if we go up to the y-axis, that's going to be 90 degrees. Go another 90 degrees, that's 180. Another 90 is 270, and another 90 is 360. Okay, so to go to 70, that's going to be about right there, and there's that terminal side. Okay, negative 160, well, I'm just going to go backwards. So that would be negative 90, that would be negative 180, negative 270, negative 360, which 160 would be about right there, and there's that terminal side. 430, so I'm going to have to go around more, so 360 plus 90 would be 450, and I don't need to go any further, so that's going to be a full rotation plus a little bit more, and there's that terminal side. Okay, so a radian is a unit measure based on the arc length. So if you think about a radius, the radian is that same measure, but it's the arc length. So over here's a pretty good picture of this. So here's our radius. This length and this length are the same. Okay, so that length, a radian, is just the same length, but of a radius. Okay, hopefully that makes sense. I'll explain it more in class, hopefully. But the radian measure, that's what radians are, is just the radius, but as an arc length. Okay, and so that means there are 2 pi radians in a circle, which is the 360 degrees equals 2 pi radians, which means that 180 would equal pi radians. Okay, so to convert from degrees to radians, or back from radians to degrees, from radians, or from degrees to radians, you multiply by pi radians over 180. And then to convert to degrees from radians, it's 180 over pi. So degrees to radians, we're just going to take that 30 and multiply it by pi over 180. You can do this in your calculator. If you just do 30 divided by 180, you're going to get like 0.16666. Change it to a fraction, you get 1/6. So that's the same as pi over 6. Okay, or just reduce the fraction. Like 30 goes into 180 6 times, so it's pi over 6. 150 times pi over 180, that's going to be 150 pi over 180, which is 15 pi over 18, which is 5 pi over 6. Negative 220 times pi over 180, which is negative 220 pi over 180, which is 22 pi over 18, which is 11 pi over 9. Negative 11 pi over 9. Okay, now radians to degrees. We're going to multiply by 180 over pi. Notice those pi's are canceling. And I just kind of rewrote that. So that's the same as 4 times 180 times pi over 3 times pi. Well, the pi's cancel. And then 3 goes into 180 60 times. So that's 4 times 60, which is 240. Okay, or you could just, in your calculator, do 4 times 180 divided by 3. This one, same thing, pi's cancel. 36 goes into 180 5 times, so 5 times 5 is 25. Last one, pi's cancel. 4 goes into 18, 45, or 180, 45 times. 7 times 45 is 315. Okay? All right, now coterminal angles. That is an angle in standard position with the same terminal side. So that means that we just have two different angle measures, but they're ending at the same point. Okay? To do that, let's think about this as a picture. So if we have 65 degrees, that's about right there, right? To get another angle that is the exact same as that angle, I would just have to rotate 360 degrees, and there would be another one, right? I'll put an arrow so we know which way I'm going. You could also rotate it backwards 60 or 360 degrees, and there would be another one. Or we could rotate it 2 or 3 times. So we could go 1, 2, 3, 4. There's another coterminal angle. Okay, there are infinite numbers of these coterminal angles. So the easiest way to do this, especially if we need a positive one and a negative one, well, let's just start by subtracting 360 and adding 360. So 65 minus 360 is negative 295 degrees. So that's one of the coterminals. When you add 360, you get 425. Okay, this one, I'm just going to subtract it first and you get 180. Well, if I add to 560, I'm going to get another positive one, and I need another negative one. So let's just take that 180 and subtract 360 again, and you get negative 180. Okay? These ones, I did it a weird way on this video. Well, not really weird. I just didn't, I'm using fractions here, so it gets kind of harder. You can convert these 2 degrees, change them, find their coterminals, and then convert it back if you want to, okay? I'm not going to do it that way, though. So if I have 13 pi over 18 minus 2 pi, I'm subtracting these, so get a common denominator. You get 13 pi over 18 minus 36 pi over 18, which is negative 23 pi over 18. For this one, I'm going to add 2 pi, so over 1, get a common denominator. So we're adding 36 pi over 18, so that's going to be 49 pi over 18. Okay, one thing to remember, if it starts in radians, it needs to end in radians also. Like if your answer starts as a radian, it needs to, or if the problem starts as a radian, your answer needs to be a radian. Okay, this one, let's subtract 2 pi, so I have to get a common denominator of 9. So it's going to be 14 pi over 9 minus 18 pi over 9, which is negative 4 pi over 9. And let's add it. So we're adding 18 pi over 9, which is going to be 32 pi over 9. Okay? Now, reference angles. Okay? Reference angles are going to be huge, 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 huge. For an angle in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. Okay, so that is your reference angle. And I'm going to draw a couple diagrams here. So if it's in the first quadrant, actually, here, I want to get like a new screen. Sorry. Let's do a chalkboard. Cool. So if it's in the first quadrant, oh, that's kind of hard to see. First quadrant. Okay. So if we have some angle right here, this is the reference angle. I'll just put RA. Okay. If it is in the second quadrant, so let's just, let me go back to this one. So say this angle was like, I don't know, 50 degrees. Well, then this reference angle would also be 50 degrees. Okay, but for this one, let's say that here is our angle, because now we're in the second. This right here is going to be the reference angle. Okay, and let's say that this was 120 degrees. Well, to get from 120 to this would be 180, you would have to go 60 more degrees, so that would mean that our reference angle here is 60 degrees. Okay, if we go into the third quadrant, so we have some angle down here now. our reference angle would be this angle. That is the reference angle. Okay, and let's say this is 240. Whoa, sorry, I ran off the page. That says 240. Well, to get back to the x-axis, if this was 180, I would have to subtract that 60 degrees. So again, that reference angle is 60. Okay, and then if it's in the fourth quadrant, so it's here, let's say that this is 300, this is in the fourth. Well, this right here would be our reference angle. And to get from there to there, it would be 60 degrees. Okay? So let's look at these ones. So if we have 225, it's always positive, it's always less than 90 degrees. So 225 is about right there. We need to go back to the x-axis. So we need to go back to 180. So if you just do 225 minus 180, you get 45. So that reference angle is 45. Negative 310. I'm just going to change this. So I'm going to find its coterminal angle. I'm going to add 360. So that's the same as 50, which means that reference angle there is 50. Why did I write 45? That was wrong. This is wrong. It should be 50. Sorry. Mistakes. Learn from your mistakes. It makes you smarter. At least that's what they tell you. This one, let's change it to degrees. It's easier to graph degrees. So that's going to be 120. To get to the x-axis, we have to go 60 more degrees. So that's going to be, our reference angle is 60. Change this back to radians. So that's going to be the same as pi thirds. Cool? This one, Pythagorean theorem, just x squared plus y squared equals c squared. Except in this case, if we look over here, we've already labeled our c as r. So that's why we're using r. So sine here, opposite over hypotenuse is y over r. Cosine is x over r. Tangent is y over x. And this theta might kind of throw you off. Think about it as if it's inside there, okay? Which means that cosecant is r over y, secant is r over x, and cotangent is x over y. Okay, so let's look at this. If we have this point 5, negative 2. So there's 5, negative 2. And we need to find the trig values for this. So first we need to figure out what is the hypotenuse of this. So we do 5 squared plus negative 2 squared equals c squared, which is 29 equals c squared, so c equals the square root of 29. Well, now sine is opposite over hypotenuse, so negative 2 over 20 square root of 29. Rationalize that and you get negative 2 squared, so 29 over 29. Cosine is adjacent over hypotenuse, so 5 over square root of 29. Rationalize it, you get 5 squared, so 29 over 29. Tangent is opposite over adjacent, so negative 2 over 5. Cosecant, we can flip sine, so that's just going to be the negative square root of 29 over 2. Square root of 29 over 5, and negative 5 over 2. Okay, remember to take the quiz. Goodbye.